Hey everyone, Shashank this side, currently working as a senior data engineer at Expedia and previously worked for companies like Amazon. So in today's video, I'll be talking about the process of designing a data pipeline. So before starting our actual discussion related to data pipelines, if you are new to our channel, then make sure to subscribe and press the bell icon. So being a data engineer, our actual role and responsibility is to design optimized, scalable and fault-tolerant data pipelines. And based on different business use cases, sometimes you might be working on different data domains as well. Let's say you are working for an e-commerce company, then data would be related to the e-commerce. Let's say you are in the telecom, so you will be calling it as a telecom data domain. Similarly, healthcare, finance, banking, and multiple other data domains. So the very first step of designing the data pipelines is to understand these data domains in a correct manner. And this is a really crucial step. When we design the data pipelines, we invest our most of the time in this phase because understanding of the data domain is really important. In your organization, or let's say you are working for a client which belongs to a specific business, they might come to you with a specific problem statement. And being a data engineer, if you don't know about that particular data domain, you won't be even able to understand the important terminologies and like what kind of matrices they are expecting from this kind of data. So getting that understanding is important. Plus, this will also help you to identify what would be the multiple data sets you need to consume from the sources, what would be the important relationship among them, like the connection with the help of primary keys and foreign keys. And this will eventually help you to identify that what kind of columns or what kind of important data sets you need to bring into the system, because the end users or the clients sometimes will come up with a vague problem statement and they would expect you to bring every single data set. And being a data engineer, you always look forward for the optimization, scalability and fault tolerance. And it's not recommended, or it's definitely a bad practice to bring the data sets, which is definitely not necessary. And if you don't understand the data domain, the relationship and how these matrices are getting generated, then in that case, like without any knowledge, you are just bringing everything and you are adding extra cost in your project because it will be unnecessary data processing. So this is the very first step. Understand your data really well, and then the other technical steps will be involved while designing the data pipeline. So the second most important point while designing the data pipeline is the choice of the data sources. So while consuming the data or the data extraction process, data can come from multiple sources, sometimes the databases, distributed file system and APIs. And I'll tell you why it is important to understand the data sources. So as we know, like data can come from multiple sources based on the type or based on the, let's say, OLAP, OLTP data or API related data. So we can consume data from multiple sources, and that will be completely depend on the businesses. Let's say they are using the MySQL database for their data storage. So you will be consuming the transactional data from there. And let's say you are working on a use case where you need to process the data which is coming from sensors, then you will be getting it from IoT devices. And let's say there is a web application which is generating some data for you, so you can consume it via APIs as well. So understanding the core capabilities of every data source is also very important, because that will help you to understand which kind of computation engine you need in between, which can easily connect with those data sources and pull the data from there. So if you don't understand what kind of data source you are going to use, probably you won't be able to come up with an efficient design. And also the important part is you need to understand how this data is getting populated on the source side as well, whether it is a real-time data or a batch data, or how it is getting stored there, the file formats, right? These kind of things you need to understand from the data source perspective, and that would be the initial step of your data extraction. So the third important step in the data pipeline design is to determine the data ingestion strategy. So in the data processing, there are majorly three important data ingestion strategies. First is incremental data load, second is the full load, third is absurd kind of load, and I will explain each of them one by one. So first let's talk about the incremental data load. And when I'm talking about these data ingestion strategies, so it will again completely depend on your business use cases and how you are going to perform the analytical queries. So first let's talk about the incremental data load. So in that case, what will happen, whatever data source you have picked, so based on some timestamp values, you will try to bring the data in smaller chunks. Let's say first time you just hit your data source at, let's say, 11 p.m. and till that point, whatever data was available in the data source, you pulled it and you dumped it into somewhere after the processing. And after, let's say, 15 minutes, your pipeline again executed. So from 11 p.m. till 11:15 p.m., whatever updated or newly created data was present there, you just pulled it and processed it and then again dumped it into the downstream system. So this is the incremental load, like based on different timestamps, you are pulling the data and dumping it into the downstream system. Now talking about the second data ingestion strategy, which is full load. So in full load, it will mostly depend on the use case. If every day you want to process something, so in that case, what will happen, whatever data is available at your source end, so completely you will just erase your target table, which was previously loaded with some data, and whatever fresh data is available for current day, you will pull that entire data set, will process it and dump it into the downstream system. And the third strategy is upsert kind of data ingestion. So upsert kind of data ingestion, what will happen? This is also just a variation of incremental data load. So here what will happen? Let's say you pulled some data records and among them few records were already present in the target table because you processed these kind of records few days back, and that relation can be checked based on some primary keys. So if you find these kind of common records, what will happen? You will remove those old entries from the target table and whatever new record you have pulled, you will ingest it. So that is a kind of updation we are doing, or not. Let's say we are not deleting the records from the target table, we can update few values of it. And the two data ingestion strategies, the incremental and upsert kind of load, that is mainly designed for the historical data as well, because every day you are processing everything and you will be keeping it for some timestamp, let's say till 1 year and 2 year, you will be processing these incremental data. And this kind of ingestion strategy is needed when the analytics team want to analyze data per day basis, per hour, per week, something kind of this strategy. Then you need to the dump data into this form, like incremental or upsert kind of load. But let's say your analytics team is only concerned about for a specific range or the batch data, let's say 1 year or 1 day, 1 month, 6 months. So in that case, you will just pull the data for that entire time window which the analytics team has provided and will do the full data load. So that's how you can understand based on the use case which data ingestion strategy you need to pick for your data pipeline. So after completing these 3 steps, the 4th step will be to design the plan for the data processing. So far we know in the big data domain, we have multiple frameworks available for different kind of data processing. So the important data frameworks which are available, Hadoop is there, Spark is there, Flink is there. So based on the use case, like you want to do the batch processing and real-time processing, you need to decide which one is a good fit. And I will explain how you can decide it. So in this data design plan, or you can say data pipeline design plan, you will majorly focus on the choice of the data framework. So let's say you are concerned about the batch data processing only, then you should pick the kind of framework which is a right fit for it. For an example, there are 2 popular frameworks like the Hadoop, which is completely designed for the batch processing, and also you can leverage the Spark as well, which is the most demanded skill set for the data engineers as well. Let's say you are designing a near real-time data pipeline, then you can leverage the Spark streaming. And let's say you are trying to create a completely real-time data pipeline, then you can leverage the framework like Flink and along with the Apache Kafka. So based on the kind of data processing you are trying to do, you need to pick these kind of frameworks. And the second thing which you need to consider while designing the data plan or while designing the execution plan for these pipelines, that it should be completely scalable, completely optimized and fault tolerance. And how you can achieve it? If you know the exact comparison between all the big data frameworks like Hadoop, Spark, Flink. So based on the criticality of your data pipelines, you can pick whether this particular framework will help me to achieve the scalability part, the fault tolerance part, and the optimization part. And this is the most crucial plan, and don't take it lightly, because your architecture or your data pipeline ingestion will completely depend on this one, because these are the frameworks which will help you for the data transformation. So try to get the good understanding of the main and core capabilities of each big data framework. So after the data processing plan, you would have coded all the logics, like whatever business rules your business teams has provided to you, you would have coded it like on the source data sets, whatever transformation, deduplication logics, filtration, data validations, multiple things you would have done. And the next important step would be to decide the downstream system or the storage part for the transform data. And this is also one of the important points to be considered in the data pipeline design, because based on the use cases, you will decide which data storage is the good fit for your use case. So I'll give you the examples that what kind of data storage you can pick. So far we have multiple data storage available as well. Let's say you want to process or transform the data and dump into the downstream system like the S3 and any persistent system like HDFS. And we will be also having options for the NoSQL databases. So let's say your team or the analytical team wants to query data time to time, very frequently, and ad hoc queries, right? So you will be looking for a kind of data storage which is scalable and partition tolerant as well. And here the NoSQL databases like Cassandra, MongoDB, Elasticsearch will come into the picture, because they are the good fit for the analytical queries. And let's say you are trying to dump your transform data either in the data lakes or in the data warehouse. So based on these two terminologies like data lake or data warehouse, you will decide which one needs to be picked. So let's say if you're trying to create the data lakes, you can choose the persistent storages like S3, HDFS, or anything like that. And similarly for the data warehouses, you can either pick any cloud service like the AWS Redshift or any other open source data warehousing service like Apache Hive. So that's how you can decide based on the business use case or the end analytical impact on the queries and how they gonna consume it, design it. And let's say you are processing the real-time data and somehow your dashboards are getting populated with the real-time data. So you might be also dumping data into the transactional databases like MySQL and Postgres. So based on the like batch or real-time data processing or the impact on the analytical queries, you can decide the data storage. So after deciding the data storage part, the next step would be like scheduling your jobs or the workflow management. So in the big data, so far we have most efficient workflow managers like Apache Airflow, Azkaban, and Apache NiFi. So based on the use cases, you need to decide that how you gonna schedule your pipeline and how do you wanna create the dependencies. So I'll explain it with an example. Let's say you want to derive or you want to populate a table which is named as table C, and this will be derived with the help of two data sets, let's say, which is stored in the table A and another data set is stored in the table B. And we have even created a separate pipelines for the table A and table B. And based on some transformation logics, we will be populating the table C. So here we can see this interconnection or the dependencies, like the pipeline C or the table C is completely depend on these two pipelines, table A and B. So we should definitely have some mechanism in place which can take care of these dependencies and also can help us with the schedule part as well. Because multiple times we might be running our pipelines on specific times, let's say 1 hour, 5 minutes, 10 minutes. So these schedulers or workflow managers will help us with the pipeline dependency management. Now the last step of the data pipeline design is to set up the pipeline monitoring or the governance tools. So this is also very much important, because you cannot assume that 24/7 your pipeline will be running successfully. there can be multiple instances where your pipeline might get failed because of any unavoidable circumstances. So what you need to do, you need to set up some mechanism so that you can monitor the health of your pipeline, or what kind of incoming data you are getting, the scale or the peak volume, so that you can identify that how my pipeline is working for a specific timestamp, and you will be also able to like log the all kind of errors or any kind of failure if it happens. And this step is really crucial because sometimes there are pipelines which are really critical. Let's take an example of financial data, right, which is really important for any bank, even to figure out if there is any fraud transaction is happening. And even for a 1 minute or 2 minute your pipeline is down and you are not able to get that alert or any kind of notification, that means you will be losing the customer trust. And that's why these kind of monitoring tools and governance tools will come into the picture, and we need to use it for all kind of monitoring failures, errors, the health, and these kind of tools like we have Grafana, we have Datadog, we have the PagerDuties, which will help us for these kind of pipeline monitoring. Now I will take an example of dummy created pipeline and will try to explain you that how we designed it with the help of all those points or the steps which we talked previously. So here is the pipeline, and one by one I will explain whatever points we talked about, how this pipeline is taking care of it, and how you can even design these kind of pipelines. So as discussed, first thing, let's say you got all the understanding related to the data domain, you understood it. And now the second point was to choose the data source. So here what we are going to do, we are trying to pull the data from the transactional database like MySQL. Okay, so this will be our database where let's say some web application was there which was dumping the data into the transactional database, and our analytical team wants to just consume this data with some transformation and they want to analyze it. So now being a data engineer, it will be our responsibility to create this pipeline end to end along with the transformations, extraction and the load part, right? So the database part is here. Now the next part was the data ingestion strategy. So after deciding this MySQL part, so we know this database will have multiple tables and those tables can have timestamp columns as well. So we can use those ones in order to get the incremental data. So here the strategy we are going to follow is the incremental load. After that, there will be the data processing plan, or you can say the data processing framework, which will be doing the actual transformation. So here what we are going to do for the incremental load, we are using the Spark. So Apache Spark will be the framework which will consume this data from the MySQL database on increment basis and will apply all the business logics, the duplication logic, the filtration, the data validation, and let's say there was some join operation, group by operation, whatever is actually needed to create the transform data for the business analytics, that will be done and taken care by the Apache Spark, right? So that was about the data processing framework part. Now after that, the next step was this data storage. So here again, based on the use cases, like whether we are concerned about the data lakes or the data warehouses. So data lakes are mostly for the cold data, or there we are trying to dump the data in its raw format so that it can be used for multiple use cases and mostly for the analytical queries for very long period of time, let's say 1 month of data and 1 year of data, or even a 1 week of data. So that kind of queries, this data lake part would be efficient and we will be storing our data there. So for that one, we can use either HDFS and also AWS S3 if we are going with the cloud. Or let's talk about the data warehouses, because data warehouses are the services where we dump our transform data, actual transform data which we have prepared in this Spark application, that will be dumped into the data warehouses. And let's say we are generating 4 or 5 transform data sets. So we need to generate it in such a way so that there is a proper relationship among them, so that we can use it with the help of the join operation to get the meaningful insights. So data warehousing services, if we want to use, we can use Apache Hive as well. And if we are going with the cloud services, then AWS Redshift is a very, very popular data warehousing service. Now this part is design. Our source was decided, our data processing engine was decided, and then our output storage was decided. Next point was to schedule this pipeline. And since we talked about the incremental load, so let's say what we are using Apache Airflow here, and here we are scheduling our pipeline to get executed after every 15 minutes, right? So Apache Airflow will take care of this triggering point and will keep on monitoring the timestamp. For every 15-minute of window, it will trigger this pipeline, and this pipeline will do its job for the incremental load. And whatever data we are processing, so we need to monitor it as well, like the data governance part, which is very, very much important. So we can just transfer the logs, whatever we are generating or whatever we are doing in our Spark application, that can be transferred to some logging system, and on top of that we can use these monitoring and governance tools like the Datadog and PagerDuties. So if there is any kind of mishappening which is currently going on with our pipelines, that will be captured by these governance tools, and they will notify us and we can quickly take the actions. And at the end, like the last layer will be the presentation layer, where either we can populate any dashboard which will be used by our business users for the query and the data representation part, or let's say we can provide a direct access to our data warehousing services where our end users can run their ad hoc and analytical queries, and they can populate, or you can say they can get the meaningful insights of this transformed data. So that was this entire architecture, and I have covered all the steps, and this is the most generic way to design any scalable, fault tolerant and optimized data pipeline. So that's what I had for you guys in this video, and I'm pretty sure if you are an aspiring data engineer, then you would definitely take this video seriously and will be following all the important steps which I talked about for the data pipeline design. And if you find this video really informative, make sure to like it, and for more such type of content, subscribe to Scaler.